Please copy down this first fact. The square root of a times b equals the square root of a times the square root of b. Okay, so what I want to do right now is I want to get this second fact. Let's not worry about this second fact. Let's just focus in on that first one and put this to the side over here. We'll come back to that later. But right now, let's really understand this fact because it's going to help us simplify that square root of 20 that we had on the previous slide. So if we have the square root of 20, that is not a perfect square number. You want a perfect square number inside the square root, Mario. The square root of 16 is 4. The square root of 25 is 5. It's beautiful to have a perfect square number inside the square root. So the square root of 20 is not a perfect square number. What we want to do is rewrite it with multiplication so we could get a perfect square number. So 20 is not a perfect square number. It's pointless to break it down to 2 times 10 because 2 is not a perfect square, 10 is not a perfect square. By the way, if you forgot your perfect square numbers, go ahead and make the list. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 36, 49, 64, 81. And you know, I'll stop right there. But yeah. So we have all these perfect square numbers, and you want to rewrite the square root of 20 as one of these perfect square numbers, 4 times 5. You don't want to do 5 times 4, even though 5 times 4 is 20. You want to put the perfect square number first and the other number second. Now, the above fact right here says that you could, when you have two numbers inside being multiplied together, you could take that root and split them. Split them to each of your terms. So we're going to split the root. And of course, the square root of 4, the whole purpose of changing 20 to become 4 times 5 so you could get a perfect square number in there. So the square root of 4 really is 2. And the square root of 5, you're going to leave it the square root of 5. Now you're supposed to look at the square root of 5 and see if you could continue breaking it down with multiplication so you could get a perfect square number. But that's not the case. That is as far as you could go right there. Let's try another one. Like the square root of 18, for example. Yes, you could rewrite that as 6 times 3, but 6 is not up here on the perfect square list, and 3 is not up here, so you don't want to use 6 and 3. What are you going to use with 18? 9 times 2. So you're going to rewrite it. I want to do it on the side since we're running out of space. I want to rewrite it as 9 times 2, and this fact above lets us know that we could split it. So it's really going to be the square root of 9 times the square root of 2, and we all know that the square root of 9 is the nice, beautiful number 3, and the square root of 2 it stays. So there's your answer, 3 square root of 2. Let's do one that's more fun. Check this out. The square root of 32. Aha. What could I rewrite that as?
4 times 6.
4 times 6 is not 32. 4 times 8 is 32. So yes, you could break it down with 4 times 8, and then you have to split the root. You have the square root of 4, the square root of 8, and the square root of 4 is 2, and you bring down the square root of 8, but then you realize and you say, hey, the square root of 8 could be broken down further to 4 times 2 once again. And of course, you're going to bring down the multiplication of 2 that's out in the front, and then you're going to split the root, and you have the square root of 4 times the square root of 2, and then you realize that the square root of 4 really is 2, so you're really going to have 2 times the square root of 2, which the final answer will be 4 square root of 2. So, listen up, guys. Check this out. Now, I really just wasted time right there, because what we're supposed to do is look at our perfect square number list, and yeah, 4 times 8 is 32, but if you take a couple more seconds and just look at the next couple of numbers, 9 times something give you 32? 9 times 4 is 36, not 32, right? So 9 doesn't work, but how about 16? 16 times something give you 32? Yes, 16 times 2. So if you just take a couple of seconds more, when you're at the square root of 32 and you're like, wait a minute, yeah, 4 and 8 work, but 16 times 2 is faster. Use the highest perfect square number available to you. So when you split the root, what is the square root of 16? 4. What's the square root of 2? Square root of 2. Look, you got straight to your answer. So compare, you have all this work, or just 16 times 2, split them, you get 4 square root of 2 as your answer. Same answer, just a lot less work. So my recommendation is don't just jump on the first perfect square number that works. Try to use the highest perfect square number, right? And at the end of it all, there's only a couple of numbers that it could be. So just test those other higher perfect square numbers to simplify. Let's try some more. How about the square root of 125? Now, if you have that perfect square number list up here, it's pretty easy. You just look through them. Now, 64 times something give you 125? No, because 64 times 2 is 128. Doesn't work. 49? No, it doesn't work. 36? No. 25. 25 is the highest perfect square number that actually works. So 25 times 5, right? There's 5 quarters in the $1.25. So when you say 25 times 5 and then split the root, your final answer will be 5 square root of 5. I hope this is making sense to you guys. So what we're going to do, that's in a nutshell, that's using this first fact. Oh, I forgot. You could use it backwards. You could use it backwards. Now, what do I mean by that? Let's say I have the square root of 2 times the square root of 8. Instead of splitting the root, it's already split, you could actually put them together. You could actually write them together, and that will be the square root of 16, because 2 times 8 is 16. Technically showing my work, it would be like this. And then you get to the square root of 16, and then the square root of 16 is 4. So sometimes it's a good idea, instead of splitting, if they're already split, to put them together. Not always, but in this case, it is. Does that make sense? No? Okay, so how about this? Let me go with the square root of let's say the square root of 18 times the square root of 2, right? That's a good idea to place them together, write them using the rule backwards and writing them as 18 times 2. Why is that? Because 18 times 2 is what? 36. And the square root of 36 is what? 6. You see how we got that answer? By putting these guys together. Now, you could have done it a different route. There's always many roads to the same place in math. For example, if you wanted to, you could take the square root of 18 times the square root of 2 and then split the square root of 18 to 9 times 2. That way you could simplify the square root of 9, but you still have a square root of 2 and a square root of 2. So the square root of 9 is 3, and then the square root of 2 times the square root of 2 is technically the square root of 2 squared, which ends up giving you the square root of 4, which takes you back to 2. So you really end up with 3 times 2, which is 6. But that's a lot more thought process than actually just multiplying 18 times 2, that's square root of 36, the answer is 6. So there's many roads to the same place, it just depends on how you look at it. Okay, so let's go back. Let me get this all out of the way here. Let's go back to this fact. And if you guys are taking notes, it's great. We're also going to have to split square roots. Just like you could split them with multiplication, if you happen to have a fraction, which is really division, you could also split that root to the numerator and to the denominator. Okay? So when would that come in handy? Like let's say you had the example, the square root of 4/9. Well, that will become the square root of 4 over the square root of 9, which is really 2/3. Easy peasy? Lemon squeezy. But, and that's a pretty big but, yes, you don't want to leave a radical in the denominator. Okay? So it gets a little challenging, because whenever you have a square root in the bottom on the denominator, you're going to have to get rid of it. So let me move this to the side. Let's say I had, ladies and gentlemen, the square root of, let's say, 4/3. Okay, you're going to split the root, and you'll have the square root of 4 over the square root of 3, and the square root of 4 is 2, and square root of 3 stays on the bottom. Now, the problem is you cannot have a radical in the denominator. And in this case, you really do have a radical in the denominator. So let me rewrite this thing. 2/3, or 2 square root of 3, If I want to get rid of the square root of 3, I'd have to square it in a sense, right? The opposite of a square root is a square. So, in other words, I'm going to have to multiply both top and bottom by that identical square root of 3 value. Because the square root of 3 times the square root of 3 ends up being the square root of 9, which takes you back to 3. So your answer here will be 3 on the bottom, and on the top, 2 times the square root of 3 is 2 square root of 3. So that would be your final answer right there. You cannot leave a radical in the denominator. And we'll pick it up here tomorrow.